Well, here we are, Lesson 11A, Population Growth. As you studied exponential growth, you probably um, said more than once, that things just can't continue to grow exponentially. Whether it is a population, energy consumption, the rate of deforestation, or even internet use, most things that grow at an exponential rate cannot continue to do so. Consider a metropolitan area that has been growing at a relatively constant rate of 3 to 4% each year. When the roads get too crowded, water and sewer capabilities are maxed, and that population gets so dense that safety and health are compromised. What will happen to the population growth? If you haven't already hit pause, this is a great time to do so. You can read through this, write down some answers, look at the objectives, keep on going to the information after the objectives, and then question 2 and question 3, and then come back and we can work on these together. Some possible answers to question 1 are that the growth may slow down or even level off, that in some cases the population may decline. The objectives for this lesson include that you'll understand that a population that grows at an increasing rate and then continues to grow at a decreasing rate might be modeled logistically. You're going to be able to sketch a model for a population that increases at an increasing rate. You're going to be able to sketch a model for a population that increases at a decreasing rate. And then you're going to be able to identify behavior in a graph, draw conclusions about that behavior, and predict future outcomes. Smith Island is a complex of 3 parallel semi-tropical islands located in Brunswick County, North Carolina. This county has been a popular site for television series such as Dawson's Creek and movies such as Weekend at Bernie's and I Know What You Did Last Summer. The deer herd on Smith Island is a recent population, originating sometime in the mid-1980s, and it originated then. The herd was then estimated at 30 in 1996. Hunting is not allowed, and natural predators are practically non-existent, except for alligators that occupy freshwater ponds. Thus, the population of deer increased at an increasing rate in the years following 1996. Suppose that in 2002, the study found that the density of deer was approximately 19.5 deer per square kilometer. The area of Smith Island is about 48 square kilometers. Estimates based on research showed that the densities ranged from 11.9 deer per kilometer squared in some areas to 58.8 deer kilometer square in other areas. So question 2 reads, according to the 2002 study, what was the deer population on Smith Island in that year? So the 2002 study is right here, and it found the density of deer was approximately 19.5 deer per square kilometer. I like using words, looking at what's going on, because then it says, according to that study, what was the deer population? So when we get done, we want to know how many deer. So I'm going to need to know some more data here. Excuse me. I have this many deer by square kilometers, and if they want to know how many deer are on this entire island, I need to know that the area of Smith Island is about 48 square kilometers. So using dimensional analysis, and there is a resource in the back of your 1332 book, which is in my math lab, or you bought it in hard copy. And once we look at dimensional analysis, our square kilometers are going to become 1, and then I'm allowed to go ahead and multiply, and my final unit will be deer. So grabbing a calculator, I'm getting 19 5/10 times 48, and I get that there are 936 deer in 2002 on the island. I'm going to keep reading question 3. And again, if you haven't stopped, this is a great time to stop, hit pause, go work on it by yourself, and then come back and let's do this together. But it asks us on question 3 to create some representations of changes in the deer population over time. Part A says, using the information from these 2 paragraphs that you're looking at right now about the deer population, complete the following table. And on the table, it has the year and the population. And so they have a year of 1980, 1980, and then it has 1996 and 2002. And so looking back through the population, through the paragraphs, in the mid-1980s, that's when we originated. So the deer count at the very beginning, well, in early 1980, we had none, because mid-1980s is when they started the deer population. The herd, it says, was about 30 in 1996, so we got about 30 in 1996, and then 2002, we just calculated it as 936. So I'm going to translate this to what you're looking at on question 3A, but I wanted you to see where it's coming from in the paragraphs. So I'll join you at 3A, and we'll keep going with 3B and beyond. So I have no deer early in the 80s. 96, we have 30 deer, and in 2002, we have 936 deer. It asks us to make a quick hand sketch of the data in the table. Should the points be connected? Why or why not? So when we go to make a quick graph, remember that time is usually on the x-axis. So we could start with like 1980, and we can jump around. We can, let's see, how efficient do I want to be here? I'm going to go ahead and do 1990, 2000, 2010, 2020. And then as far as our deer population, we're going up to almost 1,000. So I'm going to just do 250, 500, 750, and then 1,000. And so in 1980, and by the way, there's a break here that we're not starting and going 0 all the way up to 1980. But in 1980, we're at, I'm going to change colors, we're at 0. And then in 1996, which is up closer to 2000, we had 30, and that's not much above 0. Then in 2002, which is over here, we had 936, which, whoa, it spiked on us. So should it be connected or not? And I would say yes, because over here at 1985, we're going to be able to show where we started getting deer, and then in 1990, some more deer, and then we're going to see where this is spiking up. So sure. Sorry, y'all. I can't see what I'm drawing. I'm guessing, and looks more like a snake headed up there. But the general idea is that it is doing what you see here. In general, describe the rate of change of the deer population. And in general, the deer population is growing slowly at first, so a different color. So look at what's going over here. It's growing, but it's increasing at a not very fast rate, and then it grows very rapidly here. It is all still growing, but boy, it is spiking in the growth right around this area right here. Moving on to question 4, there's something to read and the questions to answer, but first I want to show you a drawing from the book's answers. This is taken from our curriculum. Notice how it has a nice title. It has a nice title for the y-axis and a nice title for the x-axis. And then it puts those key points like 1980, 1996, and 2002, and that's a very nice looking graph. So the islands, especially Bald Head Island, continued to develop and became more urban, with developments replacing farms and fields, and residents began to worry that the deer population would destroy the maritime forest as well as ornamental plants found naturally. There were also an increasing number of deer automobile conflicts. Describe what you think would happen to the deer population on Bald Head Island between 2002 and 2010 without intervention. You can go back and look at my graph or the one that I showed you from them or the one that you have drawn, and then looking at 2002 to 2010 without intervention, write down something. Most likely, the deer population is going to continue to increase, but the growth is going to slow down. They're going to be getting crowded. So move on to number 5, and if you have not already completed it, go ahead and hit pause and then join me after you do. So question 5, in your flashcards, in your glossary, whatever you've got going on, you need to write down that there's this thing called a parameter, and it's a value that helps define a relationship, some kind of relationship. And one example of a parameter is the carrying capacity of a species. The carrying capacity in a particular environment is, I'd have another flashcard and start writing down, it's the maximum number, the maximum of that species that the environment can support with its food, its water, and other types of environmental limitations like those deer automobile conflicts. The carrying capacity of deer on Smith Island has been estimated to be 33 deer per square kilometer. Let's say that the deer are projected to reach the carrying capacity by 2020. What will be the population of deer on Smith Island? And then add your question back to our chart. Okay, so I've got 33 deer for every square kilometer, and they're wanting to know what will be the population of deer. So when I get done over here, I want to know the number of deer. Well, to get to the number of deer, I'm going to turn this into a multiplication. I need to multiply it by something that's going to eliminate the square kilometers. And from earlier in this lesson, we know that the island is 48 square kilometers. So that makes our kilometer square become the unit of 1. And that means we're down to the amount of deer, or the unit of deer. So 33 times 48 will get 1,584 deer for the population on part A. B asks, describe what you think is going to happen to the rate of increase in deer during the years leading up to the point when the deer population reaches the carrying capacity. So just a few more thoughts here. What we calculated is that by 2020, this island's going to reach carrying capacity, and carrying capacity is 1,584 deer. So I'm going to go put that on the chart, but then there are a couple of questions that are going together here, like describe what you think is going to happen as we lead up, we get closer to the carrying capacity, and then sketch a curve that you believe really best represents what's going on from 1980 to 2020, and compare. You don't have group members to compare to, so I'm going to be your group. So you go ahead, we won't be able to do D except compare with you and me. Go ahead and work on parts A, B, and C. I've come back over here to question 3A. I've already put that 2020 is going to be our carrying capacity year, and we'll have 1,584 deer. And we'll go ahead and draw a couple of more things on our chart. We're now going higher, so we'll have our 1,250, our 1,500, and that's just a little over 1,500. So I'll go ahead and stop. Well, let me go ahead and put 1,750. And our carrying capacity is going to look something like this. It's where we're going to max out. It's our limit. And when we're looking at our graph, remember how we started low with 1980, and then our our growth was just going crazy, but then it said something about as we approach this carrying capacity, it's like our growth may start to slow down as it approaches and hugs up to this carrying capacity. You all are looking at part B, and it says describe what you think is going to happen. And so it could be possible that the deer population will increase, but at a decreasing rate as it gets closer to this carrying capacity. And that's what I'm trying to illustrate right here, is that it's still increasing, it's just not spiking like it was and increasing at that increasing rate. They ask us to sketch a curve. I have a curve, that's the purple one, and then compare the curve drawn with those in your group members, what's about the same, what's a little different. And so I'm going to go grab the one from this lesson. And so this is their answer from the curriculum, and it looks similar to the purple one I have. And this is where it would be good for you to look at what you drew, what's going on here, and asking yourself and making note of what's the same, what's different, and do you want to go ahead and go with what you see, or you want to go ahead and stay with what you have on yours? We'll keep investigating this. Another definition you need to put on a flashcard or glossary is culling. Culling is the process, and I've got the wrong color going here. Uh-oh. Oh my, cancel. I was trying to give me some writing space. Okay, culling. It's the process of removing breeding animals from a group based on specific criteria. And it can be done to reinforce certain desirable characteristics or to simply reduce the number of animals. And you may have heard of things along those lines here, like with fishing. If the lake gets too crowded, they can start dying, and then you end up with no fish. The village council approved the culling of deer on the island, and the goal was to preserve the health of the herd and to protect the island ecology from damages of overgrazing. And so they've been taking or doing culls ever since 2001. This is where I was trying to give some writing space, but I'll just go ahead and say, knowing now that actions were taken to decrease the population of the deer, sketch a new curve from what's going on from 1980 to 2020. And a reminder, the culling started in the year 2001. And this is where it would be really good for you to go ahead and do your own drawing before you look at this one or the answer from theirs that I'm going to show you. But we don't know the severity of the culls, we don't know the numbers, it can vary. But if this is 2001, and this is where the culling starts, the culling means we're losing population, but then it's going to grow back, but then we'll lose some, and then it's going to grow back and we'll lose some. So the end of it is going to be gaining and losing population. And this is the drawing, the sample that they included with the curriculum. And you see back here in the culling, it's going to decrease in population, and then there will be growth rate in the population, and then culling, and then growth, and then culling. But remember, there was the phrase carrying capacity, and the carrying capacity was 1,584, and that's a number around which we could be going up and down, maybe past, maybe not. We'll keep talking about this. But this does end Lesson 11A. You need to check your syllabus to see if you have more lessons to do that are due this week. If there are, get those done, get your homework done. And if not, then I'll see you next week when you have a whole new set of videos.